Alberto, are you here?
Yes.
Great to have you. And I found you via your ODSC talk, so I'm very excited with what you have. Yeah, and I obviously went through the notebook after I merged it, but yes, I did go through it. So yeah, really excited about it. Yeah, over to you.
But yeah, it's great to be here, and thank you very much for the invite to be here. It's a great pleasure. Just wanted to talk a little bit about DSPy in financial services. But before doing so, I wanted to make a quick intro of myself. I'm Alberto, and my background is in data engineering, big data, and machine learning. I've spent the last 15 years or so building streaming analytics applications with a focus on machine learning, such as risk prediction applications, high-frequency trading systems, anti-money laundering systems. I've spent a lot of time in financial services over the last 15 years. I'm also a former AI co-founder, AI startup co-founder. So some 7 years ago or so, was a technical co-founder and CTO of a company called Human.ai, where I, along with a set of other people, built an insurtech business, an insurtech platform, ultimately, leveraging a lot of telematics data and machine learning models, such as behavioral models, geospatial models, etc., to ascertain risk of vehicles in real time, and then being able to price that risk, quantify it and price it. So that startup was acquired by a very large insurance organization end of 23. And then beginning of this year, I joined Citi as director of GenAI Engineering, where some of my responsibilities include the likes of building applications across the entire organization. Some of the applications, GenAI applications, serve already tens of thousands of users. And part of my focus is around AI agents, building advanced RAG pipelines, and also building evaluation frameworks to ascertain and assess how well we perform in terms of the outcomes from those GenAI applications. Right. So back to DSPy then. My understanding is that you guys already have a level of understanding about what DSPy is. So I won't spend a huge amount of time going over the basics, but I'd like to build upon some of the concepts that I'll be showing to you guys later on. The goals for the session is to understand, and I'm sure everyone here already understands, the challenge of LLM prompting, and how this challenge is particularly aggravated in regulated industries, especially financial services and other industries as well. Then discover how DSPy can help mitigate those challenges. And then we'll walk over different strategies when leveraging DSPy in terms of ensuring that our application performs at the right level. Right. So just to frame the problem, building a complex system with LLMs requires breaking the problem into several different steps, then iterating over prompt versions until each step works well, then tweaking all the steps so they work all together, and finally generating synthetic data so that you can tune each step. So that's a very involved process, and takes quite a bit of time to get it right. In terms of financial services and other regulated industries, we have some additional challenges. Some of them are outlined here on the screen. One is explainability. So the regulator will ask us to explain those outcomes that we produce through any application, whether it is AI driven or not. Mainly because we want to be able to treat customers fairly. There's a whole bias conversation, there's a whole fairness conversation when it comes to serving customers in regulated industries that I'm sure most of you are aware of. Then the second one is reliability, and how lots of the processes, decision-making processes that we leverage in financial services and other industries as well, require a set of complex chain of thought, if you like. No intended in a sort of GenAI manner, but sort of it's very much a chain of processes that one needs to ascertain and obtain relevant outputs and good outcomes from each of them as input into the next one, etc. So that there's a whole pipeline you need to rely on, and that's what I'm trying to say. So you need that level of reliability. And then finally, consistency. When it comes to serving customers in financial services, there is literally no room for hallucinations. You can't determine or not determine to give a mortgage to someone based on some hallucinated generated outcome from an LLM. That simply cannot happen. So we need that consistency, and at the same time we need to treat all customers the same and according to their circumstances and fairly, as I said earlier. Right. So this is a bit of a 101, but I suspect most of you already know some of these aspects. DSPy is a framework that's come out of the Stanford University. There's a link for the paper over there. Feel free to read it. Some 30 pages or so. It's actually really good, really interesting. But the four aspects that I think are most important about DSPy is that is able to separate the program flow from parameters, which is very important when it comes to optimizing those parameters independently from the program itself. It really helps improving consistency by compiling applications for different LLMs and when you make changes in code, or when you have additional training data sets and you want to rerun your entire compilation, you can have the final compiled version. You can start leveraging from that point onwards, and that gives you a really good level of consistency. Then there's obviously a systematic layered optimization, which is sort of similar to what PyTorch does to neural networks, in terms of being able to build layers and then optimize against their parameters, so the model can learn, the framework can learn the parameters across all the different layers, and then finally reduces the effort when it comes to building prompts that work the way you expect them to work. Right. So a couple of additional things to talk about DSPy. There are mostly four important components. Three of them are the ones on the screen. The fourth one I'll elaborate a bit more on. First one is signatures. So signatures, as you probably know, in DSPy is a declarative way of telling the framework how to interact with an LLM. So it saves you the hassle, or saves you from the hassle of having to build your very specific prompts to perform a certain task, and it basically just transforms into or converts into very simple declarative ways, such as those examples you've got on screen: question, comma, context, arrow, answer. Same for like summary. You can pretty much do anything, but it's all self-described. Then you have modules. There are several modules such as predict, which is the one you use then along with signatures to interact with the LLM. But so this is the case with chain of thought that incorporates an additional level of reasoning. So these are the building blocks where the parameters are literally just the inputs and the outputs contained within the signature that you are then able to optimize against certain metrics. But equally, there are other ones like React, when you want to build a more agentic framework, or you want to use DSPy in a more agent-like approach. And then finally, metrics, which is super important. I think if there's anything, there's a good, important takeaway from this session. It really needs to be metrics, because this is where you're going to be successful or not when it comes to implementing your DSPy application. And this is essentially what you're going to be optimizing against. So you define your parameters to optimize against, and the rest of the work is done by DSPy. So we'll dive into what that looks like a bit later on. But first of all, and before moving on to the last sort of building block, this is what the workflow looks like. So you've got a set of modules that you can combine between each other. You send across to optimizers, which is the missing block here. And the optimizer is going to do a lot of clever stuff. And you basically end up compiling a version of your application once it's fully optimized, and that is essentially your optimized pipeline you can use later on. So let's look into optimizers, which is the jewel of the crown. So there are several different types of optimizers. You've got the likes of FewShot learning optimizers, where you have LabeledFewShot, BootstrapFewShot, and a few variants of BootstrapFewShot, where you essentially pass on several examples of the or demonstrations, if you like. That's what normally the DSPy term of examples or few shots are called. They're referred as demonstrations. So you pass on demonstrations that you have from a training data set, or you essentially train your application or your optimizer against a set of metrics and produce the best possible examples, the best possible demonstrations, which is what you sort of do with BootstrapFewShot. Then you also have instruction optimization. So GoPro is purely instruction optimization. We're not going to dive too much into that, but sort of MIPRO also covers that, as well as FewShot or demonstration optimization. So it covers both aspects: instruction, so making sure the instructions that you pass on to the LLM are the best possible ones you can produce, and then secondly, what the examples are, or the best examples to pass along. And then finally, you've got things like Bootstrap fine-tune. Not going to have enough time to talk about that one, but super interesting if you want to fine-tune your own model. That's the third parameter. Essentially, you can optimize. So the other two are essentially instructions, and then the few shots. And then the third one is this one, basically, LLM parameter weights, which you can do through Bootstrap fine-tune. Right, so we're going to be walking through our use case, which is risk assessment for loan applications. It's sort of an interesting use case in that is free form, but it also requires a good level of reasoning. So it's free form in its output because it's going to produce a report of why or why not someone should get a loan. But it's going to go over a very decent level of reasoning across certain parameters. We have examples about those about potential loans, etc. So we're going to leverage those with DSPy. So just to start with, we do some initial bootstrapping. So this is something I'll be showing in the code later on. Just bear with me for a sec. So we can make this a lot more interactive when I get to that. So just bear with me before I get to that point, and then I'll open it for questions, and we can make it a lot more interactive. But in essence, you start with bootstrapping what you want to do. You select a model you want to use. I'm using Claude a lot these days, but by all means you can use whichever model. Sort of important to limit the number of tokens you want to use, because with DSPy you can actually produce massive prompts unless you are not careful. So there's an element of being cautious here, and you want to start tuning this type of parameter as you go along. Then let's move on to the first approach, which is ZeroShot. And you're probably thinking, ZeroShot, you've not mentioned that one. What is ZeroShot? Well, ZeroShot is basically nothing. Is not passing anything special. We can draw and start comparing against as we move along the optimizers. So ZeroShot, all it's going to do is just pass on the information about the applicant, which you saw on the previous screen, and then it's just going to produce an assessment. So how do we do that? There's an actual ZeroShot. So you can build this ZeroShot module in DSPy, but just very simply passing on a question, analyze the applicant's financial information, and return a risk assessment. And you just pass on the actual applicant, and it's just going to use this signature question, arrow, answer. So super simple, nothing special. So it will generate this prompt. So this is what DSPy does under the covers. So given the field's question, produce the field's answer. That's it. That's what it does. And it produces this risk assessment, which to the untrained eye might look all right, but it's actually pretty bad because it's very vague, makes statements such as debt to income ratio. Well, existing debts are relatively low compared to annual income. This is really vague. No data is backing any of these statements. Respectable salary for a 35-year-old, really, really bad. Something being on the higher side. And then it's actually telling you to verify the applicant's ability to be able to make monthly mortgage payments comfortably, etc. So it's not really giving you any solution. It's just giving you a very standard out-of-the-box response with no, with no thorough answer. So let's move on to an actual optimizer from DSPy, which is LabeledFewShot. So LabeledFewShot is similar, but this time we're just going to pass on a set of labeled answers, labeled examples even. So labeled demonstrations. So the way we do that is, and I'll show you the data sets we have for the notebook in a sec. The way we do that is, first of all, we implement the signature, which is quite simple. You've got two input fields. One is the question, and the second one is the applicant. And then you've got an output field, which is the answer. One thing we are introducing here when defining our risk assessment module is a chain of thought. So we're going to, just by doing this, rather than running a predict here, we are adding an additional level of chain of thought to the LLM call. And we're going to be running 3 instances of the prompt, basically. So super simple way of just incorporating a chain of thought into your pipeline. And again, we just define our forward function within the module, which is the one that is going to be called and get populated, and then we'll get our predicted answer. How do we get the data? We have the data set that you'll see in a sec, and basically that's what we make as our train set. What we essentially do is just pass on a to the compile method. We just pass on the train set, and we just use the module we defined earlier. That's all it does. So all we're doing is use chain of thought, pass a few examples out of your data set, and give me the response from the LLM. So nothing too complex. So this is the prompt that it generates. Analyze the applicant's financial information, blah, blah, blah. And it will incorporate an example. So this is the example. It's not greatly formatted here, but I'll show you what it looks like later on the notebook. And let's see what the risk assessment is. So it gives a more thorough answer. It gives still some not great statements like income is solid, existing debts are manageable. Not brilliant. But it does some relatively okay things like giving you what the debt to income ratio is. So that's okay. So that's not too bad. But then also says it's only been at his current job for 5 years. So not sure what what data was the LLM trained to believe that only 5 years in a job these days is not a lot of time. But yeah, certainly not wouldn't say is too little time. So let's see how we can improve this. Moving on to BootstrapFewShot. This is getting more real actually. So we're going to be using training data, but in this occasion we're going to incorporate a metric evaluation. The way it works is for our metric evaluation, we're going to create an additional signature that is going to make an assessment on a set of metrics that we define. So our metrics in this case are going to be whether the risk assessment is correct and whether it is complete. And then it will make the assessment. It will just get an answer yes or no, and bear with me because this, you're probably thinking, well, I mean, this sounds like a bit of a basic metric, but we'll move on to something a bit more advanced later on the notebook. So again, use the training data set, and when we compile here, what we're going to actually do is get the samples, the demonstrations that scored the highest during the BootstrapFewShot compilation. So what we're going to be generating is a prompt that will contain the best possible demonstrations based on our metrics. And then we can proceed and run that. So this is going to be the prompt. It's going to incorporate a set of demonstrations. This looks similar to the previous one because it's essentially doing the same thing, but just selecting what demonstrations to incorporate. And the risk assessment is just going to be a bit better. So it does, it does score better by removing some of the not so great examples that we had in our data set. And it already provides a much more suitable sort of response. So it still has some vagueness in terms of having significant financial commitments, blah, 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 but is really giving you a final answer, low to medium, low in terms of risk. So, and it's going to be reasoning about it. So this is the reasoning. This is coming from the chain of thought. So the model or the application will also produce this to back the answer. So I mean, you can read it yourself, but it gives a bit of a reasoning behind each decision is making, or each statement is making along the way, and it does some calculations. So is well supported. I would say this is a risk assessment that is at least well supported. And then finally, the last one we'll look into is MIPRO, which is not only going to be evaluating or optimizing against the best possible demonstrations, but also the best possible instructions along the way. So the combinations of the best demonstrations along with the best instructions all together. This is going to result in a lot of LLM calls. So be aware of that, because this might incur in quite significant cost. This is the sort of thing you do once, and to train or to obtain your compiled application that you can, from that moment in time, carry on using. I'm just seeing
Alberto,
some questions. Yeah.
Do you want to take questions?
So let me check the time. So what I'll do is I'll move on to the notebook, and then I'll be answering questions as well. So I'll just finish this. We'll see that this in the notebook. Just one last mention here. What's coming, what's next. So choose modules and optimizers based on your use case, and also on how much training data you have available, and put a lot of focus on evals. I think that, for me, is super key. Evals is really, really important. Just building on that, defining and building the right metrics is paramount. Be aware of costs, I've just mentioned. React agents is super interesting. Bootstrap fine-tune is a very interesting area. If you want to train your LLM, you want to fine-tune your LLM, DSPy is a good framework to do that, because it combines all the required elements to be able to do that for you very, very easily. Right, okay, so a couple of QR codes in case you guys want to connect with me on LinkedIn, and this one is for the code, which is linking to the code I'm just about to share, but I'm assuming that's going to be shared separately anyway. So let's do that. I'll look into the questions. Will the slides be made available right after the lecture? I'm more than happy to share them. Yes. Oh no, but the code will be. Sorry, it won't be. But at the same time, you can reach out to me if you want. And I can. Let's see what can be done. We'll take it offline, Nirant and myself. Does DSPy support multimodal? Of course, yeah. Or is there an issue? I don't think I've done anything multimodal, but okay. Oh, for GPT-4 Vision, this is back from May. I've not tested it, to be honest. But it's a good question. So, but this is showing us close now. So I'll investigate. I've not really used multimodal with DSPy. Was the example in the previous slide manually written. So I'm going to show you actually what the dataset looks like. So yes, is basically the dataset or the train set is it's written, it's anonymized or tokenized rather, and yeah, it's written by a human, and it's something I've taken from a public location. Trying to think whether it was yeah, I think it was a public location, Hugging Face potentially, but I'll have a think. I'll let you know about it. I think this coming from Hugging Face actually. What are the metrics? How can one quantify the quality of the output? Nice. So that is exactly the question I was hoping for. Okay, so you'll see that in due course in the next few minutes. So I'm just going to skip over. So this is the thing I mentioned earlier. I unfortunately lost on the reboot my metrics on Arise Phoenix, which I was producing. I need to see if I can bring it back up. Because I really wanted to show what it looks like using that. But in the interim, what I'll do, it's potentially possible, is not being saved. Or is it? Okay, no. So what I'll do basically is just go over the outputs in here. It's not a problem at all. But just to set the scene, what I do here is basically push all my data to Phoenix. I think you guys are aware of Phoenix already. I think I saw on the course there was something around Arise. So Phoenix is sort of the open source poor man version, if you like. It's still quite useful when you combine it with open inference libraries. So what I'm doing is basically using DSPy instrumenter and Anthropic instrumenter, and basically pushes your traces across to your endpoint. And it's really good to see everything just flowing in there, and what calls are being made, what modules in DSPy are making what call, etc. So I'll skip through this bit. By the way, the data set is something like 30 records, so it's not huge. But essentially, I'll move on to the bit around the last question. So you see large prompts, some outputs. This is the LabeledFewShot reasoning, blah, blah, blah. So you've seen this on the slides. Now this is the more interesting stuff. BootstrapFewShot, as you saw on the slides. Again, very long prompt. This is the prompt used. DSPy has got a really cool function, which is this one. You can use your LLM worker, the one you defined earlier, inspect history n equals 1, and it will give you the last prompt he used. And so you can actually see how it's actually prompted the LLM. So yeah, you see here is actually given a full demonstration to the LLM. This is important because what you actually have on the dataset. I wanted to show this on Phoenix, but I can still show it here. What you have in the dataset is basically the applicant information. So nothing too specific. It's actually relatively short. Gives where the person works, the loan requested, any other debts, annual income, age, and then the answer, which is just the actual analysis. Okay, so nothing else. So not the reasoning. What we do with or from BootstrapFewShot onwards is actually produce the demonstrations using that dataset. So those demonstrations will actually include the reasoning element, the chain of thought element. So the LLM is going to go, you can think of it almost like layers. It's going to go through each of the examples you want to incorporate, and then it's going to make requests to the LLM to obtain the reasoning for the examples, and then it's going to evaluate the full demonstration, which includes the applicant, the reasoning, and the reasoning is come up with, and the answer it's in the data set, and is going to evaluate it against the evaluation metrics I showed earlier. So just to remind you all what my evaluation metrics were, these are not great, okay? These are pretty poor, but this is also what you will see everywhere when any sort of DSPy tutorials, anything that you look online on DSPy, you'll see this sort of metric. And I think this is really letting the team down, because your assessments are not going to be great if your metrics are not great. This is very, very generic, if you see what I mean. So this is just answering yes or no, and is getting the examples that got the most number of yeses. So just to show what better sort of metrics look like, this is the implementation of DeepEval metrics. I don't know if you are familiar with DeepEval, but it's basically a framework. It's becoming quite popular these days, that uses LLM as a judge to go over specific metrics. Now, there are lots of metrics for DeepEval. And I'll show you what it looks like. So you've got the likes of summarization, answer relevancy, faithfulness, contextual precision, recall relevancy, hallucination, bias, toxicity, and you can build your own metrics. So each of those have been built in a very specific way, and I'll show you an example of what they look like. Some of them are quite interesting for this use case. Bias, for example, we don't really want our demonstrations to want in our responses. But the really cool thing is it has an implementation of GEval. So GEval is a framework, or it's a concept, if you like. There's a paper, you've got the link in there. Basically, it's a way of leveraging LLM as a judge and defining the criteria for your evaluation metric and what the evaluation steps are to get to like a more precise metric evaluation. So this is what it looks like. So my risk assessment metric, now advanced function, the one I'm testing against is now going to look like this. I define my test case using LLM test case, which is coming from DeepEval. So this is how you define your test case. You've got input and actual output. Input is the applicant, actual output is the risk assessment. And I've defined here 3 metrics, but obviously you can define as many as you want. The more, the better, as long as they make sense. The more concise they are, the better. So I'm just using bias metric, which is one that's coming out of the box, bias metric. I'm using answer relevancy metric, also out of the box. And then I'm using GEval, to create my own custom one, which is called coherence. What is the criteria I define? Well, determining the actual output is coherent with the input. And basically the evaluation parameters are the input and the output as defined in my test case. And these are my evaluation steps. Okay. And here is where you can go really, really sort of meticulous about what is it that you want to specifically test against. And this is the point where you want to iterate over and make sure you get the most out of your metrics. This is just an example. Some of the ones I've defined, are very, very long and, incorporate lots of different metrics. But basically what we built here is a compound score. The bias metric is actually a reverse score. So is the higher the score, the more bias it is. So which is why we do 1 minus the score. So the lower the better, and then answer relevancy and coherence, and we divide it by 3. So what we want to do is get the demonstrations that score the highest across this evaluation. And as we've done before, we have our data set, and we call our risk assessment metric advanced function as the metric evaluation. So this is what then makes all the difference. This results in lots of calls to the LLM, because each of these evaluation metrics is an additional call. Some of them are several additional ones. Just to give you an example, answer relevancy metric actually divides the whole answer into sentences, and is going to evaluate each sentence individually to ensure that the sentence is still relevant to the context and the input. But equally, bias also produces several different LLM calls, and obviously the coherence one we've defined will check against these different steps, etc. So it will just escalate very quickly in terms of the number of calls, but what you get in return is a very, very optimized application. Right, so and that's what we do, and this is the response we get. So this is essentially the response we get, and we have the full prompt in here with the reasoning. The reasoning incorporates all these calculations. It's a lot more specific. These are basically the demonstrations that have scored the highest, and I only include a limited number of demonstrations. So I tell it just to include 4 demonstrations, because otherwise your prompt can get very, very large. So yeah, that's the way it works. You will see on the MIPRO one, which is actually using MIPRO v2, that I'm also using the same risk assessment metric advanced as my metric function. So it basically does the same thing, but also combined with instruction optimization. This essentially keeps exponentially creating more and more calls to the LLM, but in return you get a very optimized output. It actually asks you if you want to go ahead. It's going to result in very high utilization. Shame I can't show you on Phoenix, but from memory, just so you understand the number of tokens that these produced. So I think LabeledFewShot, it was just under 100 or just like 20 something or something like that. BootstrapFewShot produced something like 300 or 400. 400,000. No, is that right? No, some 30,000 tokens, something 30 to 40,000 tokens, and then MIPRO combined or using risk assessment metric advanced, the one you just saw with DeepEval, consumes something like 1.5 million tokens just to compile the MIPRO program with these settings. So it's a lot. It cost me a good $20. I took one for the team and ran it. But yeah, just be aware of that. This is the sort of thing that obviously you want your employer, your company to cover for, and obviously iterate over this process as it makes more sense, and fine tune, make changes as you see fit. Another question was, can I connect DSPy, LLM, and tools? Yes. There's no issue with that. You can essentially build whatever you want on top of DSPy modules, basically, and you can leverage signatures and modules, combine them with tools. So yeah, they are all building blocks, so there's no issue with that. Does that all make sense? I think we just about tipping the end of the hour. Were there any other questions? I encourage you to visit the DSPy repo and also the documentation. Documentation, I have to say, isn't probably the best. It could be improved, and is actually being improved more recently, quite a bit. Still needs some work, but you'll see a few tutorials out there, and yeah, my main concern about those tutorials that you can Google, that anyone can Google, is basically the lack of actual real optimization when it comes to putting together real evaluation metrics and ones that are or can substantially modify your outcomes. All right. That's it from me. Anything else? Any other questions, or shall we leave it there?
I think folks will have more questions. And Vignesh, are all your questions answered? Just to quickly double check.
Yes, all my questions have been answered. Yes.
Okay, cool. Yeah, I think that's it, Alberto.
No, I have one question. So
Yeah.
we talked, I think I brought this up earlier also. So we talked about like online LLMs, and sometimes we generally run offline or local LLMs, right? And they have restriction in terms of the size that we can run. And I saw that a lot of things are being given in DSPy, like in terms of context. And so do we have some sort of recommended context size that we should be targeting to ideally work with DSPy? Because online, I think they have more than 128K or maybe more than that. But in local world, can we handle with a lower context size and still get the same results?
It really depends on your use case and how large your training set, each of the records in your training set is. Mines weren't very large. You saw them like the answers and the applicants. So that's not super large, and that means that you can perhaps play it with smaller context. But having said that, if your use case requires a large training data set or records that are large within your training data set, or you need to incorporate more demonstrations, then it's hard to avoid the prompt to be larger than one may hope.
Okay.
Alberto. Were you able to put this into production? Was like the first question. And second question, did you like explain like any simple methods like F1 score, this pass of it for the data set?
The line wasn't great, and I don't think I heard much of the question. Sorry, can you repeat it, please? Oh, okay. Yes. So, I mean, this is a use case that this specific use case isn't in production. This is a test use case that is similar to some of the use cases I've implemented. Unfortunately, I'm not allowed to actually show a full use case from the bank because of security reasons. But this is the sort of what I've shown is basically the sort of approaches that I've taken within the organization and in a previous life as well. Did you compare metrics like F1? I didn't, but it could be a good exercise to do that as well. Right, so I've now got all my traces going into Phoenix. So these are all the traces. I've categorized them by the optimizer. So let's go over the different optimizers and what the output looks like on Phoenix. First of all, is notice that well, thanks to the instrumentation I've used with OpenTelemetry, using DSPy instrumenter, Anthropic instrumenter, and then later on OpenAI instrumenter as well. I'm able to get the tokens. So that's actually quite important. If you just start using Phoenix without those instrumenters, you won't be seeing any of that. But yeah, you can see the difference in terms of the number of traces and the number of tokens used across each optimizer. So ZeroShot is very light, but then you start getting into LabeledFewShot, which includes a number of demonstrations or a number of examples in the prompt that gets a bit bigger. But then the real thing actually happens with BootstrapFewShot and MIPRO, where you get a significantly higher number of tokens, and obviously traces already over 100 for BootstrapFewShot and well over 600 for MIPRO. But let's start over with ZeroShot. Nothing really super interesting here. All we were doing, just as a reminder, is basically passing on the applicant data and just using our signature from a question get an answer. So that's exactly what happens, is using predict and the signature. So it's nice because you can already see what elements from DSPy are intervening here. And this is the input that gets produced by DSPy when you use that signature. And it then passes on the applicant's financial information, which is that one there. The output gets better formatted here. You can see the actual output, which is, as I said before, is not really good. Is actually really poor. Doesn't give much of an assessment that is subject to any calculations or any reasoning. It's just making some very generic statements. So not much to see here. So let's move on to LabeledFewShot, which is marginally better, still not great. So for LabeledFewShot, what we're doing is we are incorporating examples from our train set. So these are the examples we have. So just some 30 records, not a huge data set, but it does the job for now, and it allows us to see what difference it makes. So what happens here is it generates 3 runs of the same program, and that's because we tell it to run free runs. That's part of the parameterized chain of thought. That's the actual second thing that is different from the previous ZeroShot, that we are introducing chain of thought in this case. So what we're going to get is more of a reasoning behind anything that it outputs. So let's look at what it looks like. So again, the prompt is very generic. It's just using still the signature, and it incorporates the actual examples from our data set. So all of these are examples that you can find here. Okay, so these examples are from I think Kaggle or Hugging Face, one of the two, can't remember. But yeah, it's open source data set, and it produces a, well, slightly better response, mainly because of the chain of thought component we're using. That module is sort of going over some calculations and is reasoning over the particular circumstances of the applicant, and then based on them is producing an answer. So that's the answer you actually get, but you also get a reasoning block. Cool. So again, nothing particularly interesting there, but we can then move on to the next one, which is BootstrapFewShot. And what I'm going to do is skip through the one where we had the this metric function, which is pretty weak. This is the sort of metric function you'll find in lots of tutorials online, and it's not particularly great. It becomes very binary. So you're just making an assessment based on a couple of statements from which you get a binary response, and then getting the best potential examples or the best potential demonstrations. But what I'm going to do is skip through that one and go straight into our improved BootstrapFewShot using DeepEval. So this is a reminder, this is our test case. We have a bias metric that we're using out of the box. We'll see what it looks like now on Phoenix. We have our answer relevancy metric, and then our own metric, which we've created using geval with our own evaluation steps, the criteria, etc., etc. So let's take a look at what that looks like. And that obviously already produces a significantly larger number of requests. So this is this is sorted from the oldest. So this is the first request that gets sent. Again, sends 3 demonstrations, and still using chain of thought. So let's take a look. So what is doing here is still the same prompt. Nothing changes on the baseline prompt, if you like. But what we're doing here is we're passing on a set of examples from the dataset, and we are using another record from the dataset to evaluate against. So rather than doing it directly on what we'll do later on, just our actual input applicant, is essentially getting this record from Jane Doe, and it wants to get the reasoning for that one applicant to get to the result that is got here based on these other examples, which are also from the same data set. So you see the rest of the data set, part of the rest of the data set is in here. So that's how it's going to start iterating over and trying to get to the best possible reasoning that will actually get it to produce the best possible result across the test data set. And how does it do that? Well, it essentially starts using the metrics function. So within the metrics function, this is the first one, the bias metric. This is entirely DeepEval. DSPy is using DeepEval in this case, but these requests come entirely from DeepEval. They are produced by the DeepEval framework using the bias metric. So it actually produces 3 requests to the LLM. As a reminder, the LLM is used as a judge. So it's going to want to divide the output it got from the previous generation, and it's going to try and get a list of opinions. Okay, so it gives some examples as to what opinions are, and give some instructions as to how to do that. And then this is the actual, you remember from Jane Doe, our first example there that we were trying to build the reasoning for. And basically what happens here is it's going to make an assessment on that output, and it's going to produce a list of opinions. So in JSON format, so that list of opinions is basically what we were requesting first. Then the next step is, for that list of opinions, we want to give a verdict whether that opinion is actually biased or is not biased. Again, some examples include some rubrics for bias, and then requests response in JSON format with a verdict, either yes or no. And this is what we get. No bias across all the opinions that we got from the previous step. Perfect. So the last step, as you can probably already guess, is to produce a score based on this previous step. Essentially, because we didn't get any bias, the score is going to be 0. Is lower is better, because bias is sort of an opposite sort of metric. So the lower the better. So no bias whatsoever. And there's the same process that happens across other metrics. So in this is the relevancy score, so answer relevancy metric. Again, this is going to generate 3 requests that are called by the DeepEval framework. From the output, again, we have the Jane Doe's output here. It's going to generate a list of statements. Okay, so this is the list of statements in JSON format. And now on the next step, it's going to make an assessment across each of those statements and say whether those statements are relevant to the input. We have a verdict, which is either no, I don't know, or yes. Okay, so this is the input, and these are the statements. And this is what the LLM spits out. So basically, all of them are yeses except for the second one, which is an I don't know. So we can check what that second one was. I don't know, is this one. Here's the justification for this assessment. So it's not really saying anything about the actual assessment. So it does the right thing by saying it doesn't know. Perfect. That's good. So it doesn't influence the score. And now finally we get the answer relevancy score, which is going to be a 1, because the output is perfectly relevant and addresses the input. Again, this is all generated by DeepEval. And then finally, we're going to check out our GEval metric. So you'll remember the one we built here, the coherence one, which has got the 2 evaluation steps. Those 2 evaluation steps are encoded within the base prompt and incorporate some additional things, and provides the input, and then it wants to get the output. So it gives a score of 10, because this provides a comprehensive blah, 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 blah. So it gives the full reason, which again is against your evaluation steps, which is good. So it's going to go over and do that all or a number of records in here, depending on how you've configured your BootstrapFewShot optimizer. And it will go and do that and come up with the best possible demonstrations across your entire data set. So it produces, lots of requests, and it's actually going to be easier if I sort it out the other way around. So I'll just get the last one. So in essence, this is what it arrived at. In this case, I'm using GPT-4o for the actual run of the program, and again, the base prompt is the same. It's super simple. This is using the same signature with reasoning for chain of thought. But here is going to incorporate demonstrations of the program, and these are the ones that DSPy have assessed as scoring the highest across all the previous demonstrations we've done. And obviously they all include the reasoning, because that's what we've been iterating over to get the best possible reasoning to get to the answer. So we have a few demonstrations here. So these are, so you can limit them. In our case, we are limiting them to 4. Which is why we get the 4 demonstrations in the prompt, and we ask for the financial information, the assessment for our input. Again, we can go here and see, the output. So this is the assessment. This is a much more thorough assessment that has got more calculations, more of a thought process to validate each of the parameters that we pass on from the applicant. Okay, so we get a much better response. So perfect. So that's BootstrapFewShot with our new metrics function. And finally, we'll move on to MIPRO. So MIPRO is essentially doing the same, still using the same metric function, but the main difference is that is now going to not only optimize against the demonstrations, but it's also going to optimize the instructions. So it produces significantly larger number of traces. This is sorted. This is the most recent, I believe. So yeah, okay. So again, we can start from the first one. It's going to look very similar to the BootstrapFewShot. It's doing the analysis, but notice still for the first iteration is using the basic instruction, okay, and is going to use another record, David Lee, which is there, to just basically arrive at the best possible reasoning that will result in the best possible full demonstration. So it does that by again going through the biases. This is the same by going through the relevancy score. Again, the same. and our coherence metric. So it does exactly the same steps, but the difference is it will now also iterate over instructions. So because this is a very long output, I'm just going to search for, see, this one. Okay, so let's see if one of these, oh yeah, this is it. Okay, so this is the sort of thing that is going to do to arrive at the best possible instruction. So it says, use the information below to learn about a task that we're trying to solve using calls to an LLM. Then generate a new instruction that will be used to prompt an LLM to better solve the task. Exactly what we need. So it gives some information about what it's doing. It encodes this into actual program code to define what we actually doing. Yeah. And is going to produce the actual instruction. Yeah, that's it. Oh, it jumps. I don't know why it jumps, but yeah, you can read it there. Analyze the provided financial information of the applicant to generate a comprehensive risk assessment, blah, 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 blah. So now it's a lot more comprehensive than our basic instruction that was literally based off the just the signature, the standard signature from DSPy. So that's an iteration over the instruction to make it better. But yeah, there are others, such as this one. This is a bit simpler, but is including a detailed rationale for each parameter considered. So it does include additional elements. So it's going to iterate over a few options. Yeah, so that's basically the same. Let's go to the, maybe here, let's do one of the other examples that it runs. So it combines the optimized instructions or the iterations over the instructions along with the demonstrations. So this is another instruction you can see. Consider factors such as age, income, credit score, existing debts, blah, 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 blah. And again, it incorporates the best possible demonstrations. So it's going to assess that against our metrics and eventually arrives at the best of the best possible combination across all the demonstrations and across all the instructions. And this is it. This is the actual run of the program. Wait, this is the one, or yeah, it's not that one. It is this one, the most recent one. So this is the actual run. So it's decided to use this instruction. Carefully evaluate, blah, blah, blah. Use this information, and it's decided to incorporate these demonstrations, which were the ones that scored the highest. And this is the output we get. So this is now going to be a lot more thorough, a lot more detailed, a lot more accurate, and more importantly, is going to give us the consistency, the explainability that we require for our use case, as you do in financial services. So yeah, that's it. That's the whole idea behind DSPy being able to optimize against multiple parameters, just as you would do in machine learning, you know, when using, for example, a framework like PyTorch, and you have different layers across each of them, you can sort of optimize specific parameters. So this is exactly what we do. We optimize specific parameters that we pass on to the framework. So hopefully that makes sense, and hopefully that's useful.
Cool.
Yeah, thanks very much.
Yeah.
Thanks,
Thanks
Nirant,
for doing this.
for the invite.
Yes. Thanks for doing this. Thank you, Alberto.
Right, thank you. Cheers. Bye bye.